Cool. All right, so the session's being recorded, and I'll make it available tomorrow. So let's begin. Anyway, before I begin, how was the assignment? I didn't start marking as yet, so I don't really have a gauge of how the class is doing. But I mean, how did you find it? Oh, that's good. Oh, that's very good to hear. Okay. Well, at least it was just the one question. And yeah, if anyone else is comfortable to just say how they felt about it, yeah, please just let me know in the chat. But yeah, I need to start marking it soon. Um, let me start sharing my screen. So let me know if you can see this whiteboard. Just give me a heads up. It basically says on the left, the mean lifespan of a brand name, tire, etc., etc. Fantastic. All right, so let's get back to it. So this is the next learning unit, I believe learning unit 7, and this is sampling distributions. All right, so just ignore the two blocks I have in the top and the text. I'm going to kind of give you some context um, into what this learning unit is about. Now, what I'm about to show you now, you're not going to be tested on, but I'm explaining it so that you kind of understand uh, like the theory behind this and why we're allowed to do these calculations in the way that we're going to do. All right, so um, I'm assuming everyone already watched the previous recording and they're kind of okay or just understand learning unit 6. So this builds on that. All right, so let's say I drew a sample. Right now, let's say there's different classes that do quantitative techniques. Right, so let's say there's one in Durban North, there's one in Westville, in Sandton, etc., in Cape Town. So it's all over the country. All right. What happens is I am tasked with getting a sample of students from Durban North. Okay, so let's say I was tasked with getting about let's say 50 students. All right, and then I had to basically record their marks. All right, so what I'll show here is a histogram of the marks. Right, so I'm assuming everyone's kind of okay with the histogram because we were tested on that like very early on in assignment 1, I think. So I plot a histogram, or in other words, I'm actually plotting a distribution of my sample. All right, so here roughly sketch it. And so what I find is my distribution, if I just draw the line that kind of covers or touches the apex or the vertices, all right, I get my histogram, and my distribution is centered around here. Let's say the marks for this class for quantitative techniques, the average is about 75. Okay, so this is my sample. Remember, my sample size is I took about 50 students, I believe, and then the average was 75. So that's my sample average X bar. Okay, that's the mean score for quantitative techniques. Let's just assume it's the exam that I recorded. That's not too important. It's just that I recorded the marks for some assessment and the average was 75. And I took a sample of 50 students from Durban North. Okay, so is everyone okay with that? What I just spoke about just before I move on. Okay, cool. If anyone's just not following, please let me know. All right. Now, another student, say someone else, so say Marty was now tasked with the same responsibility, but Marty had to get a sample from Westville. All right. So she did the same thing, and her sample size doesn't have to be the same. She could have sampled, let's say, n equals 100 students. It doesn't have to be the same. And then she got her own histogram, her own distribution with the average of the marks. Her average tends to be, let's say, 82. So that's her X bar, right? I'm checking if I have any questions in the chat in a second. good. All right. Thank you. Glad everyone's following. So now we continue with this. All right. So I'm going to continue with this until let's say there was 30 of us that were tasked with doing this. All right. And we got like, each of us got our own distribution. So up to 30. So I was the first person, right? Marty was the second, and up to 30 people did this, right? They got their own distribution. The sample size can be anything, right? Let's say this one was 30, all right? Now, the last one, we can make up this average. Let's say it was 80. That was their X bar. All right, so now there's 30 of us, all right? There's 30 of us that did this, and we recorded these marks. Now, what we do is, let's forget all the students that we had in each of them. Let's just look at our averages that we got. Each of us got an average. So there's 30 averages that we recorded, right? Me, Marcy, all the way to the 30th person, we've all got our own averages. Now, what happens is, if you just consider the averages, right? Let me actually just, I want to erase it. Let me just draw it here. So we just consider the averages. And now, remember there's 30 of us that recorded 30 averages. Now if I do a histogram of the averages, so that means there's only 30 people, right? And I do a histogram of the averages. So there's 30 of us, and we found the histogram of the averages follows the histogram like this. Okay. Now, basically what this histogram is here is all of, my stylus is freezing. Give me a second. Okay, so there we go. It's these 30 marks here. We're not looking at the entire class. We're only looking at the averages, and we plot a histogram of the averages here. All right, so now we can forget each one. Okay, I'm going to erase this. Okay, now when I plot a histogram of the averages, so that's basically the 30 averages that we recorded, I get this histogram. Now this is a very important property that we get from this. Okay, so now if you recall, I only took a sample. I took 50 students. So that means the class could have been 150, but I didn't take everyone. I just took 50. Marcy took, let's say, 100 students. Her class size could have been, let's say, 150 as well, or could have been 200, but she didn't take every single student, right? And all the way to the 30th person, we all took samples. We didn't take the full class. Now, the thing is, there's a good property about this histogram here for the sample means, in that where it's centered, in that if all our averages combined, if you average those averages, so basically remember we had 30 averages, right? It was me, I was the first person, I had an average of say 75, Marty had 82, all the way to the last person. I can't remember what the mark is, but let's say it was 80. There was 30 of us. Now, if we average these values, okay, what happens is we find that this distribution, this curve here, is centered around the true average. So here, mu is the true average. This is the, I'll put it here, mu. Now, what is the true average? Remember, the true average is if we had taken every single student that does quantitative techniques, not samples. So if I had taken the full class, Marty took the full class, all the way to the 30th person, we took every single student that's doing quantitative techniques, and then we average it. That's the true value. That's the true value, okay? But we don't know the true value. But what we do know is that this X bar, the average that we follows a normal distribution. Now you would remember from the last lesson, a normal distribution means it's a bell-shaped curve, right? And it has to be centered somewhere. And in our case, it's centered at the true average. This is the true average, right? And that's a cool property of the sample mean, is that it follows a normal distribution with the center being the true average, and the standard deviation. Now, what the standard deviation is basically this. Remember, last week we did this conversion from x to z, x minus mu all over sigma. Right? If you remember that, that's what we did last week. If you have any x variable that follows a normal distribution, if you want to convert it to a z-score, then you subtract its mean, true mean, and you divide by the standard deviation. Right? Now, for x bar, because it follows this distribution, if you want to convert x bar to z, right, you would use this formula instead. Z equals to x bar. Now, you don't have to memorize it. It's given to you in your formula sheet. Minus mu all over sigma. But now the difference between this and this is that your denominator is different. There's a square root over n in this denominator. That's the difference. So this formula is also given to you, and you don't need to memorize it. So the key takeaways, what I want you to basically remember from here, is when you have the sample mean, x bar, and if you want to convert it to a z-score, you follow the same step as this, but the denominator is different. The denominator is sigma over the square root of the sample size. All right? So if I want to convert my x bar value to a z, right? Remember, I erased it, but I told you that the sample size for my recorded mark is 50. So if I want to convert my 75 to a z, I would do this. I'll go z equals x bar, right? My x bar is 75, right? Minus whatever the true average is. For now, it doesn't really matter. I'll show it to you later how it come into effect. But whatever that true average is, I'll subtract the mean, and then I'll divide by sigma, whatever the standard deviation is, over the square root of my sample size. And my sample size was 50. That's how I would convert my x bar value to a z value. I'm just going to pause there. I know there's a lot to take in. But basically, the takeaways that I just need you to remember and what you're going to be tested on. You're not going to be tested on how you derive this, okay? What you're going to be tested on is how you go from an x bar value to a z, right? Versus before, you would just take a single x value and go to a z. That's the takeaway that I want you to remember. Is everyone okay with this? Or is there anything you want me to explain further? Everyone just like shocked. Feel free to please let me know how you feel. I'm going to go into the applications now. So that was basically the theory behind it, just to kind of give you some context. But maybe when the applications come in, it might make a bit more sense. But I don't have any questions. Thanks, Caroline. Thank you for the feedback. All right. Thanks, Jiveshni. Okay. So now let's get into the application part, right? So this is actually the part that you just need to focus on. I'm going to keep these two formulas on the board because we're going to use them. All right, so let's look at the left text box. So I'm just going to draw your attention to this text box here. We're going to deal with this problem first, all right? So let's read it for a bit. It says the mean lifespan of a brand tire is 50,000 miles. All right? Assume that the lifespan of the tires are normally distributed. Yeah, so this is important. Normally distributed. All right. And the population standard deviation is 100 miles. Okay, so I'll underline that part there as well. Population standard deviation is 800 miles here. And then there's also this part here where they say the the mean is 50,000 miles. I'll underline here. Okay, so say you got this tire, maybe it could be Dunlop or Bridgestone or whatever, right? And what they find is that the mean lifespan, so basically your mu, right, the true average, is 50,000 miles. All right. And they say assume that the lifespans are normally distributed. Now, that part is important because that tells you that you can use this formula. If it's normally distributed, that means you can use this formula as well as this formula. It just depends on what they ask. So that's where it's important when they tell you that it's normally distributed. Okay. And then the last part says the population standard deviation is 800 miles. So if you've been working through that practice test I gave you, um, then you'd be familiar with these symbols for the mean and then for the standard deviation, which is sigma, which is 800. Okay, so that's your standard deviation for the lifespan of the tires, and that's your mean. So the first question, let's look at this question A. If you select one tire, what is the probability that its lifespan is less than 48,500 miles? Okay, so if you select one tire, now this part here is very important. Okay, if you're just selecting one tire, okay, then you're just looking at one sampling unit. So in other words, you're looking at X only, not X bar, okay, because you're just looking at one sampling unit, right? What is the probability that its lifespan is less than 48,500 miles? So they're asking you, part here less than 48,500 miles. They're asking you what is the probability that X is less than 48,500, because X is the lifespan of the tires, right? So I'll just write that here. Oops. X is of the tire. All right, cool. So with this equation, which we need to solve, we can use this property to convert it to a z. Just like we did in the last session, remember what they're asking us, right? So if I draw it, so here is, let's draw your x-axis, right? So x here is on this axis, so x is the lifespan of the tires. X is centered at 50,000 because that's your average, right? So this is your mu. Your mu is 50,000, which is here, and it's 50,000. All right. So if I draw this normal distribution, which is the bell-shaped curve, more or less, all right. So 50,000 is here, and they're telling us 48,500. That has to be in the left of it because it's less than 50,000. So let's draw it somewhere around here. Okay, it doesn't have to be exact. So it's 48,500, right? And they're saying find the probability that x is less than this. So x less than this is this area here on the left of it. Okay, so what they're asking you to do is find this area. Okay, they're asking you to find this area. All right, now remember, if you, from last week's session, this is exactly last week's session. There's nothing different from what you did in the last learning unit. We haven't even come to new stuff. So if you're comfortable with that, then this shouldn't be too unfamiliar to you. Now remember, you need to find this area on the left of 48,500, but in order to get this, you need to convert it to a z-score because you have a table at the back of your book for that or in your formula sheet. And how you convert it to an equivalent z value is you use this formula here. All right, z equals to x minus mu over sigma. So let's rewrite this in terms of z. So that becomes probability of z now, less than, and to convert this to z, we subtract its mean following this formula here. So this is the x value, so it's 48,500 minus the mean all over sigma. And if you plug in sigma, which is 800, and plug in mu, which is 50,000, you'll get a value of, I think it's minus 1.88. Yes. So I'm gonna just erase this, and I'm gonna write minus 1.88. All right, so now we need to find this area using our table. So the equivalent sketch for x, so now I'll draw it here, sorry, for z. So now we're talking about our z-axis, which is centered at 0 instead. Okay, so the equivalent value for this x value is minus 1.88. Right, so we need to find this area here, which is the same as this area here. And if you go to your table, just like how we did last week, you will find that the area for the shaded region is 0.0301. I'm just gonna check the chat. Caroline, point. Okay, Caroline, yes, you're on the right track, but that's not the final answer. I'm glad you actually put that in the chat, okay? Because I have seen students make this mistake. So what you did is you went to your book, all right? So I'm just gonna use a different color here. I'm glad you did that because what you did is you went to your table and you looked for positive 1.88. And remember, the area you found is this area. It's the area from 0 to 1.88, which you put in the chat. And I believe that's 0.4699. I'm checking. 4699. Yes. Marcy, give me 1 second. So I'm going to explain this. I'll be back there. 0.4699. All right. So you found this area. But remember, we don't want that area. We want the area on the right of it, the shade in blue. We want this area. This is the area we need. So how we get that remaining area is we say 0.5 because half the area from 0 to infinity is 0.5. So it's 0.5 minus this. 0.5 minus this gives you this. That's the area we need. This is the 0.0301. Okay, so don't forget to take the 0.5 minus that. Does that make sense? Fantastic, fantastic. Martin, let me take your question. Will we also get to choose questions? Marty, am I saying it right? Ma Marty, is it Marty? Marty. Oh, okay. Thank you. Fantastic. Thank you for that. I've been saying it wrong all this time. I mean, yeah. Sorry about that. To your question, Marty, it's yes. You also get to choose the questions in the final exam as well. Yeah, you do get a choice. Okay. No worries. Okay. So getting back to that, so that's question A. You've basically answered question A, which is 0.0301. If you want to write it as a percent, you can. It's I think 3.01%. That's your answer. So now that's question A. Now we're going to do question B. Right? Now question B is actually learning unit 7. So this was a good question because it actually shows you the difference between learning unit 6 and learning unit 7. Question B is learning unit 7. All right. Now, what we're being asked, I'm going to erase this part here. All right, so let's get to the second question, which is question B. All right, question B. Now, the difference here is in question B, they're telling you that you don't just take a single tire, you take 100 of them. So you take these 100 tires and you want to know what is the probability of that sample mean. So you took those 100 tires. So let me put it this way, right? Um, there's 1 tire, 2 tires, 3 tires, all the way to 100 tires. So you took 100 of them, and then you want to know if you had to work out the average lifespan. So this one could be 40,500 miles. This one could be 48,000 miles. This one could be 52,000 miles. We don't know. But what we know is we want to know if we had to get the average. Okay, so we average all these 100 tires, we would get the symbol X bar because that's the average of the sample. And what we want to know is what is the probability that their mean life, so that means X bar, okay, is more than 50,200. So greater than 50,200. Erase this. That's what they're asking you. Okay, so before it was X, now it's not X. Now it is X bar. They're telling you you're taking a sample of 100, so N is 100, and you want to know what is the probability that the sample mean, X bar, is greater than 50,200. All right, so I'm just going to pause it before I solve this. Does everyone understand the formulation of this here? Fantastic. All right, just let me know if I've lost you or if you want me to go back and explain that. Thank you. Thanks for the feedback. And now we'll solve this. And how we solve this is now we're going to use this conversion to go to Z. Okay, and this is learning unit 6. So now if I want to convert this to Z, so it's going to be probability. So now I'm no longer talking about X bar, it's going to be Z greater than, and so now it's 50,200 minus mu. All I'm doing is I'm following this equation now. Minus mu, which is 50,000 from our question. So that's your mu, 50,000 divided by, okay, sigma, and now sigma, which is our standard deviation, that's 800 from our question. Okay, so it's 800. All right, divided by square root of our sample size, which is n. So it's the square root of 100, which was given to us in the question. And if you work this out, all right, if you punch this entire thing here in your calculator, all right, you should get a value of, tell you now, 2.5. And you can just sense check that for me since you have your calculator for you. Can you just give it a shot? 2.5. Fantastic. Fantastic. All right. Thanks, Caroline. All right, so if you work that out in your calculator, so check if any more questions. Perfect. All right. So what I'm going to do now is I'm going to write it here. I'm going to write this here. Okay, so we want to look at the probability that Z is greater than 2.5. Now I want you to work this out. So go and use your table and find this probability for me. I'd like you to do that now, please, if you can, and write your answers in the text, in the chat. Give it a shot. I don't really care if you get it right or wrong. I would like you to get it right, but it's actually, if you get it wrong, is actually where you learn. And but the thing is, you need to try, and because you're going to have to do this in your exam. So now's the time to do it. And if you get it wrong, then at least I'm here to kind of show you where you're going wrong. So please work this probability out for me. I'll do a sketch maybe that might help you identify what you're looking for. So this is your z-axis. Right, there's our curve centered at 0, and there's 2.5 because it's a positive value. So you want this area, which I'm shading. This is the area you need to find, and that's the answer for this question. So give it a shot. Okay, I'm going to give you a minute. You should be going to your table. Anyone? I'm hoping some of you are trying, or all of you actually. Go back to the board. 30 seconds, and I'll be very disappointed if no one's actually trying to calculate this. Not bad. Jimish, at least you tried. Caroline, okay. Okay. Good. I'm glad to see people are trying. Very good. Very good. Please, everyone, just try. Okay. Let me. Okay. So let me show how you get the answer. Right. All right. So remember, in our textbook, or in your formula sheet where you have the tables, uh, you would have this area shaded in whatever color, because your table gives you the area from 0 to whatever z value. So your table will give you this blue area that I'm shading it. Okay. So if you look for the z value of 2.5, okay, that z value, sorry, that area that you'd find, okay, just give me a second, I had it somewhere. It will be 0.4938, I think. I think it's about 0.49. Here, this blue area is 0.4938. I may have rounded it if I can. Let me just 4938. Okay, that's the blue area. Okay, so let me see what I had in the charts. Okay, so no one's got that part. But does everyone get how I got the 4938? Remember your Z is 2.5, so let me get to the table and show you that value. Everyone would be looking at this table, all right? We're looking at the Z value of 2.5, which is here. It's here. So it's it's the first value, 0.49379, which is 4938. I just rounded it. Okay. So does everyone get why it's 0.4938? Okay, fantastic. Yeah. Doesn't matter if you got it wrong, but does everyone get how that blue area is 0.4938 though? Okay, so this blue area is 0.4938. Okay, fantastic. So, but remember, we're not interested in the blue area. We need the black area. Okay, this area that I've shaded in black. That's the answer because we're asking for the probability of Z being greater than 2.5. So it's the area on the right of 2.5. But how we get that remaining area is simply taking half that area with division, which is what you put as 0.5. So half that area is 0.5. So 0.5 minus this area here, which will give you the remaining black area. And that will be 0.0062. So 0.0062. That's your final answer. Does everyone get that? Is there anything you want me to go back and explain? Um, Now's the time to let me know. Okay, fantastic. Everyone, all good? Hoping everyone's awake. Okay. All right. So that's question B. Okay, so the difference is how you get your Z value. Okay, so the formula to get Z when you have the sample mean, X bar, it's this formula that you see here on the right. The only difference from last week's lesson is the denominator. The denominator is sigma over square root n. Now, I just want to draw your attention to something. You probably will be asked for something called the standard error. Okay, the standard error, all it is, it's basically if you look at your Z formula, okay, if you look at your Z formula, whatever is in the denominator, that is your standard error. So in this example, what you have here, if you look at what's in the denominator, and maybe I'll just circle it in a different color. Oops. Whatever's in the denominator, that's your standard error. So in our case, our standard error is sigma over square root n. And if you plug your sigma and your n in, that will be your standard error. Okay, just make sure you understand that. So if you ask for the standard error, all they're asking for is whatever's in the denominator of this Z formula. Okay, and keep that in mind because in the next question we're going to do now, we're going to use that terminology. All right, so let's move on to the next question, which is the block on the right. Okay, so we're going to solve this problem on the right now. In the second text box on the right. Okay, all right. Now I'll draw your attention to this part. Okay, all right. So now it says in a certain neighborhood, it is known that 12% of school leavers are unemployed, right? And if a random sample of 150 school leavers are selected, what is the probability that the sample, okay, contains less than 15% of unemployed people? So the first part of the sentence says, there's a certain neighborhood and it is known that 12% of school leavers are unemployed. So there's something you're measuring in this problem, and that's basically the percentage of people that leave school that are unemployed. So let's say 100 people leave school, right? What we find is that 12 of them are unemployed. Okay, so if there was 200 people, then it would be 12% of 200 people, right? The percentage is the important thing. That's the known percentage. In other words, that is the true proportion. And as you would have done earlier in this course, the symbol for true proportion is pi. Okay, so the real true percentage of the population is pi. And what they're telling you is that pi is 12%. So that's the true proportion, right? The population proportion. So that's the proportion of people that are unemployed want to leave school. Um, and now you've taken a random sample of 150 school leavers. So your sample size is n, and that's 150. Okay. The question is, what is the probability that the sample contains less than 15% unemployed people? Now here you're not working with averages anymore, all right? You're working with proportions, and you no longer deal with x. You now deal with p, as in proportion. So remember, in early on in this course, if this is the population, right? It's this big circle, and if you draw a sample, right? So say you take a smaller sample here, right? That pi represents the big circle on the outside. So we know that 12% of the full population, everyone, right, are unemployed. But for the sample, right, it depends on what the sample that it depends on the sample that you take. But whatever value you get for the sample, so you'll get a different percentage of people that are unemployed if you just look at a subpopulation. That is represented by P. We generally use P to kind of estimate what the true value is by basing it on a smaller subset or sample, in other words. So what they're asking you is, okay, you've taken a sample of 150 people. So this thing that I'm drawing in the dashed line, so let me just use a different color. This small circle here in green. Yeah, this sample is 150 people. You took 150 people, right? Now what you want to know is what is the probability that this P, right, the percentage of people for the sample that are unemployed, right, is less than 15%. That's what they're asking you. So I'm going to change this color to black again. So they want to know what is the probability that this p-value here is less than, as the question says, less than 15%. 15%. That's what they're asking you. All right. And how you do this is you use the property of the normal distribution. Now in your formula sheets, you're given this formula here. You don't need to memorize it, but you do need to understand how to use it. So Z equals P minus pi all over the root of pi into 1 minus pi all over n. Now, everything in the denominator is in the square root. Okay, so don't forget that, right? Everything falls under the square root sign. All right. Now, remember what I told you earlier, that everything in the z, if you look at the z formula, everything in the bottom or in the denominator of this formula is your standard error. So this part in green, which I'm going to circle here, this is your standard error. Okay. So if you ask for the standard error, you just need to work out the denominator. All right. So we're going to use this to solve this, because once we can convert it to a z value, then we can use our table that we have in the back of our textbook to find that probability. So that's what we're going to do. All right. So before we do that, let's just work out the standard error. It'll make your life easier instead of working out every single thing in one step in this equation. As you can see, it's quite a lot of stuff in this equation. So I do encourage you to work out the standard error first. All right, so let's just do that. Right, so the standard error is just everything in the denominator. Right, so I'm gonna write that here. You can work it out in the meantime if you want. There's your pi value. okay, and there's your n. You have all the values to plug it in to the denominator. So I only want the denominator because that's your standard error. So I'm going to write st, the error is equal to square root. I'm only working at the denominator, and your pi is 12%. It's 12% into 1 minus 12%, all divided by n, and now n is 150. So can you work that on your calculator? I'd like you to do it so it's also practice on your calculator. So you can see if you're getting it right or wrong and you're using the square root sign properly. Okay, just get your value out and write it in the chat, and I'll tell you whether you're on the right track. So work this out for me. And this is important because if you get this wrong, then everything else in this question is going to be wrong and you lose a lot of marks. So it's important that you're able to do this in your calculator. Okay, so work this out. Square root of 12% into 1 minus 12% divided by 150. Okay, let's see what answers we're getting. Oops. 0.0265. Yeah, that sounds about right. 0.0265. Very good. I'll tell you now. Oops. Very good, everyone. Yes, 0.0265. That is right. So the standard error is so right here, as you said, 0.0265. Very good. Very good. So that's the standard error. All right. So now that we have standard error, so we're going to come back to this and we're going to solve this. So now we're going to convert this p into a z. So it's going to be probability into z less than. So now we're going to use this formula here. So it's going to be p, your p value is 15% minus pi. All I'm doing is I'm following this formula here. So the numerator is minus 12%. That's your pi value according to what we wrote here. And the denominator, now instead of writing this whole square root thing here, I don't need to because we worked it out. You've done it. So instead of writing that whole thing in the denominator, I just need to write 0.0265. Let me come back to the chat. How many decimals should we round up to just be safe? 4. Carry 4 if you can. Because remember, if it was your final answer, that's in the answer to the end of the problem, then you can leave it to 2 decimals, all right? But if you're still going to be using that value, like how we're doing now, because this 0.0265, we're not done with it, we're still using it. So keep it as much decimals as you can. So 4 decimals is good enough. All right. Okay. So now, if you work out this part here, right, which is much easier to work out now because you worked out the denominator, which is the more complex part. So 15% minus 12% divided by 0.0265. If you can work that out in the meantime, while I erase this, and I'm going to write it here as a shortcut because I'm out of space. Okay. So that'll be 1.13. Yes, yes, fantastic. Thank you. Thanks, everyone. So it's 1.13, and this we know how to solve. Oh man, 1.13. I'm just going to use 2 decimals because the reason why I'm using 2 decimals here is because your table only goes up to 2 decimals. So if you look at our table, you can see the z values here. It only goes up to the second decimal on the margin, right? So if you want 1.13, all right, there's 1.1, and 1.13 is It's 0.3708. Yes, fantastic. That's right, Caroline. 0.3708. So let me go back to the board. I'm gonna make some space. And I like sketching it because it kind of uh, puts it into context for me. Um, so I'm gonna draw it. This is the z-axis. It's centered at 0. And your z value, it's a positive value, so 1.13. 1.13. And remember the area that you gave is, as you said in the chat, 0.3708. Now remember, the area that you're giving me is this blue area here. Here. Oops. I'll shade it in blue. That's this area here. So this area in blue, this is 0.3708. But remember the question says less than 1.13. So less than 1.13 means, doesn't mean you stop at 0. Less than 1.13 means it's everything on the left of it, right? That's what less than means. So it means it even takes into account the area on the left of 0, which I will shade in a different color. Let's say green, which is this area here. So the answer to this problem is the green area plus the blue area. Right? Does that make sense? Because we're not saying the area between 0 and 1.13. If it was that, then it would just be the blue area. We're saying the area on the left, or everything less than 1.13. So it's this green area. As we know, half the area on the left of 0 is 0.5. So that's the green area. All right? And then this blue area is what you found in the table. So the final answer is both these areas added up. So 0.5 plus this. And your final answer is 0.8708. So your final answer for this problem is 0.8708. Or in other words, 87.08%. Does that make sense, everyone? That's your answer. Fantastic. Everyone else, that's pretty much what I want to cover today. Okay, I hope that made sense. But if there's anything you're not clear about, you can ask me now, or do watch this video again. Does help to watch it again. I'll make the recording available tomorrow. So remember the key takeaways is it's basically how you go from X bar to Z, all right? When you're dealing with averages, and when you're dealing with proportions, then you have to use the formula for pi instead, all right? But then once you get it to a Z value, then it's back to learning unit 6, the previous learning unit. Right? So that's why I told you last week, it's very important that you understand learning unit 6, because the next 2 learning units, I believe this and hypothesis testing, still uses what you did in learning unit 6, which is the normal distribution. So get comfortable with that. Okay, any questions, people? Everyone good? And do remember to, okay, one, complete your ICE tasks by the 18th of May. And also work through that normal distribution test. That's not an ICE task. I just gave it to you to kind of test your understanding. So you can actually use that for feedback for your revision. So do give that a shot. Okay. Okay. So I assume everyone's good. I'm not getting any questions. Fantastic. You're welcome, everyone. And yeah, enjoy your evening and thanks for joining. I will make the recording available tomorrow. Cheers, all.